So work example 2.23 has two questions, part A and part B. Part A is explained in two ways, and I think he does a pretty good job of it, so I'm not going to rehash that one. I'd encourage you to read those carefully. I prefer method 2, but if you like method 1, that's fine. Hi there. So part B of question work example 2.23 is actually pretty interesting. Here's the scenario. You put the 4 kilogram mass on top of the 6 kilogram mass, and you pull it to the right with a force of F, an unknown force of F, and that's what we're going to be looking for. The coefficient of static friction between the two blocks is 0.45, and the question is, how hard can you pull, what's the maximum force you can pull on the bottom block so that they accelerate together and the top block does not slide off? It's actually pretty neat. So first thing we want to consider is that we want there to be friction that will be acting between these two blocks in this direction. And we can figure out how much friction we have using the friction equation. So let's do that. So here's the friction equation, and the book uses 10 for the acceleration of gravity. R stands for the normal reaction force. So we're going to go 0.45, and R is going to be equal and opposite to the weight of that top block since it's a horizontal surface. So that's going to be 4 times the acceleration of gravity. We've been calling that 9.8. The book calls it 10. So what we get is that the maximum amount of friction between the two blocks will be 18 newtons. That's the most we can have. If we try to make it accelerate so that there would need to be more than 18 newtons of force, well, the 4 kilogram block just won't do it. It'll slide off because there's not enough friction to make that happen. So since we know that 4 kilogram block has a maximum force of 18 newtons, we can figure out how fast it's going to accelerate using F equals ma. So we basically discover then F equals ma. We find that the maximum acceleration that the 4 kilogram block can have is 4.5 meters per second squared. That's the fastest it can go. If we try to make it accelerate any faster, there's not enough friction to make it do that. So now we recognize that we want them both to go together. So the total thing can only accelerate at 4.5, and now we can solve for the force. So we go back to Newton's second law, F equals ma, and this time, however, we use the total mass of 10 kilograms because we're trying to accelerate them both. We want them to go at 4.5 meters per second, so that leads us with a maximum force of 45 newtons. And that's our answer, 45 newtons. Hope that makes sense.